I am going to demonstrate a titration by using two Burette method. Generally we perform the titration by a routine method in which one make use of the pipette and a burette. But in this two burette method you can see two burettes are there. One may call it as a burette number 1, other may be called as a burette number 2, and by using these two burettes one can also perform a titration. There are many more advantages of doing the titration by this method, because you may be familiar with the different difficulties faced by the students when they are using the pipettes. This titration is about the standardization of potassium permanganate solution with a standard solution of Fe2, that is iron 2. We are having both the burettes cleaned. This is a burette number 1 in which I am going to place potassium permanganate solution whose normality has to be calculated. You need to fill the solution above the 0 level, then whatever the air gap is there, it has to be removed, and I am trying to adjust the 0 level. This way the burette number 1 is filled with potassium permanganate solution. The other burette, that is burette number 2, in this I am going to fill the Fe2 solution which is 0.05 normal, that is the standard solution of Fe. Again I have to remove the air gap and adjust the 0 level. Now it is 0. In a clean conical flask, take out about 9 ml of iron 2 solution. In this solution, let us add 10 ml of 2 normal dilute sulfuric acid. And one can start performing the titration with burette number 1 solution, that is potassium permanganate. As potassium permanganate is a self indicator, it is not required to add any external indicator. We are titrating it till we are getting the faint pink color. Now you can see the faint pink color is appeared to the solution. The titration with 9 ml of the solution is over. One can record the reading. It is about 9.5 ml. Now generally in routine titrations students throw away the solution, but in this two burette method we are not going to throw away this solution. To the same titrated solution, once again 1 more ml of solution of iron 2 solution, that is from the level 9 to 10 only. So I had from level 9 to 10. Now one can notice the color has been changed from pink to colorless. Now once again you have to continue titration with potassium permanganate solution. Please note that it is not required to fill any burette again till you get the faint pink color. So once again you are getting the faint pink color. What is the reading is there, which is 11.1, has to be written in the place of X2 reading. Again we are not going to throw away this solution. To the same solution, titrated solution, once again add 1 more ml of iron 2 solution, that is from the level 10 to 11. Again you will notice after addition of iron 2 solution the color has been changed to colorless. Again continue titration with potassium permanganate solution to get faint pink color. We got the faint pink color. The third reading is about 11.9 ml, has to be written in the place of X3. So you might have noticed that in a short span of time we have got the 3 rings. In the old method we may require more time, whereas in this two burette method we require a lesser time. Another advantage is that the amount of chemicals or the reagents required or the solutions required is less, and hence the cost of the chemicals is also reduced. At the same time the cost of the experiment is also reduced. One can calculate the normalities. From these two readings one calculate the normality as N1, From these two readings one can calculate the normality as N2, and from these two readings one can calculate the normality as N3. See how one can do it. So, for the normality calculations, KMNO4 equals to Fe2, normality of KMNO4, let us assume it is N1 into the X1 reading, which is equals to 0.05, that is the normality of the standard given ion solution, 0.05 multiplied by 9. So, N1 is equal to 0.05 multiplied by 9 divided by X1, as 0.05 into 9 divided by X1, the value of X1 is 9.5. So, N1 is equal to 0.047. The second calculation, the value of N2 is find out by formula 0.05 into 10 divided by X2, the value of X2 is 11.2. So, by doing calculation we get N2 equals to 0.044. In the third case of the calculation, the value N3 can be calculated as 0.05 into 11 divided by 11.9, that is X3 divided by, with the value is of N3 is 0.046. And the last calculation, the average normality of potassium permanganate or KMNO4, in short we call it as N4, is given by N1 plus N2 plus N3 divided by 3. So, 0.047 plus 0.044 plus 0.046 in bracket divided by 3, we get the exact normality of potassium permanganate as 0.045 normal. So, by this 2 Burette method, one can minimize the or one can avoid the use of pipette, because many students they have got the difficulty in handling of the pipettes. One of the problem associated with the pipette is that one has to suck the solution with the mouth, and sometimes hazardous chemicals are there. So, that always there is a risk of entering of the solution into the mouth. So, that problem can be avoided by avoiding the use of pipette. Another problem with the pipette is that what is the last drop are retaining pipette, those are generally not taken out by the students. So, since we are not using the pipette, so that problem associated with the last few drops of the solutions which are not drained out of the pipette is also avoided. The time is reduced, the amount of chemicals is reduced, the cost of the experiment is reduced, and that is why the 2 Burette method I can say is a very good method as compared to the old method of doing the titration by using 1 Burette and 1 pipette.